To understand some even and odd functions, it really goes back to the symmetry that might be present in functions. Now, if you're familiar with symmetry, doing it with functions is exactly the same thing. Let's go ahead and quickly review what symmetry is. If something is symmetric, or it has symmetry, it means that there exists some sort of line on the object, such that if you fold it on that line, it would match up with itself. So, take this little diamond shape here. It has lots of symmetry in it. One good example of a line of symmetry would be one I could draw directly down the middle. If I fold it along this line, it would match up with itself. Now, some objects have several different lines of symmetry in them. So another line that I could also fold my box would be maybe along this way. Now if I folded it up along the blue line, it would match up with itself. You can keep going around this little diamond shape, maybe find a couple of more lines of symmetry, but that's the big idea. So let's take this idea of symmetry and now apply it to some of our functions. Y-axis symmetry is where you can take your graph and fold it along the y-axis. So imagine that line of symmetry as before, and it just happens to line up with this y-axis. So notice how if I have a point over here, there's another corresponding point right over here on the other side. Now this is a very special type of symmetry, and when a function has this, sometimes we give it the special name, we call it an even function. Now, as you can guess, there's probably a lot of functions that have symmetry, but not necessarily y-axis symmetry. If I had to draw a really quick example, imagine if we took, say, a similar graph. Here we go. Now this one does have symmetry, but you would not call it even because the line of symmetry does not line up on the y-axis. A second type of symmetry that graphs could have is symmetry over the x-axis. As you can guess, this works exactly like the previous symmetry. The difference here is that the line of symmetry now lines up with the x-axis instead. So imagine a nice imaginary line right there. So sure enough, any point that you can find on the graph has another corresponding point over here. Now, even though this is a pretty neat piece of symmetry, there is no other special name associated with this one. Alright. The third and last type of symmetry that we are really interested in is symmetry over the origin. Now, this is a little bit different, especially when it comes to symmetry. That's because normally when you think of symmetry, you think of flipping it over a line. And the origin is actually just a single point. To visualize this type of symmetry, what I like to do is actually visualize flipping it twice. Imagine taking a portion of the graph and maybe flipping it once over the x-axis. And then take that portion and flip it one more time over the y-axis. So flip it once, flip it twice. If you can do both of those flips and then it matches up on itself, that's how you know you have symmetry over the origin. Another way that you can do it is maybe imagine taking your graph and rotating it 180 degrees. If it matches up, then again it has symmetry over the origin. Now this particular type of symmetry has a special name. We call these ones odd functions. So now that you know a little bit more about symmetry, let's do a quick example. Here we want to graph the absolute value of x plus 3, examine it, and just see if it has some symmetry in there. So the absolute value of x is a nice V shape. Everything is being shifted up by 3 because of that transformation. So we get this nice graph right here. Alright. Now if we look at this, I can see that if I fold it along the y-axis, sure enough it will line up with itself. So I'm going to say that it has y-axis symmetry. Now remember that y-axis symmetry also has another special name. We could call this even. So be on the lookout for symmetry when working with functions. And don't be too surprised if you come across some even and odd functions.